Hi, welcome back to Affordable Tools for Chemical Engineers. So now, we have just gone through a little bit more about PT Flash in the last video. Yep. So we have already learned how to get the property packages list. As you can see, we have this list here. I already taught you also how to, insert and delete arrays. The array being the property package list as being here, so you'll be using Control-Shift-Enter a lot. Okay. Anyway, if you want to copy some of the data out, just click copy, and when you click paste, go to paste values, and this will be just the value which is Ping Robinson in this case without the formula. So that's how you can copy data out of the array. Because if you try to Control-C, which is copy, and you Control-V here, that will just give you, the formula, which is they will give you the first piece of data in this whole array. Okay, so you want to paste values, you'll become Ping Robinson. Okay, so hope that makes it clear. And now let's go back up to our flash drum case, and more specifically, what we need for our PT Flash algorithm or PT Flash function. So we already have the property pack. So okay, here we are done with this Flash algorithm as well. Then this pressure and temperature we can kind of specify it later. Now what we need is the compounds. So it says to list your component names as a one-dimensional matrix. So this is usually defined as a reference cell name, reference cell range, like A1 to A5, meaning to say it has to be a vertical cell, vertical array. So if you have water, methanol, CO2, that's how you should order your data. So it goes on saying that available component names are returned by the function getCompoundList. So what is getCompoundList, and why do you need that? Okay, so it turns out that if you try to enter any old name in the PT Flash, if you try to enter any old name in the PT Flash function, let's say you want to do water, you can just type it as H2O, methanol, you can type it as MEOH, carbon dioxide, if you type it as CO2. If you just introduce these names into the PT Flash function, the function may not recognize this as water, may not recognize this as methanol, and may not recognize this as carbon dioxide. So in fact, you have to type in the specific name of the compound as given by the getCompoundList. Meaning to say, if you want to put in like carbon dioxide, you can't type in CO2. You have to type in like carbon space dioxide. Only then will the function recognize that you are trying to tell it to calculate the properties of carbon dioxide. Now, how do you find the correct set of these names? So we have to go to the getCompoundList, and I've already prepared something similar at the bottom. So the compounds are as follows. So you have air, argon, bromine, etc., etc. You can see it's quite a very long list of compounds, right? So again, how do we make our compound list, right? So first of all, you need a property package. So I'll just write property pkg, and let's say I want the NRTL. So I'm just going to copy this here, and I'm going to paste it here. Okay. So okay. Anyway, next time when I'm going to do copy and paste, I'm just going to do Control-C, Control-V for the speed. Okay. So I can put equal get property. Oh, not get property. It's a getCompoundList. Well, if you're not sure, you can go to the function again. Go to DWsim and get compound list. Sorry, it should be compound list. Compound list here. So it tells you to get the property pack. So we already have a property package called the NRTL package. So you can just select this cell and press enter. And you're okay with that. Just press OK. So it returns you the first compound, which is air. So again, we have to do our array trick. So we just select all the way down, let's say to maybe row 409. So I'm just arbitrarily selecting a long compound, and I'm going to press F2 or F2, which actually is the same as clicking here. You just press F2 and you Control Shift and enter. So now you have a very long list, exactly the same, a very long list of compounds. You can see that the compounds, there are so many compounds that, well, yeah, which is good. It's a good thing. You have many compounds, which is a good thing, because, well, you have a wide library of things to search for. Now the bad thing is how do you find your, how do you look for how do you look for the specific compounds you're looking for? So in this case, let's say you have the system, you want methanol, water, hydrogen, nitrogen, and all that stuff. So okay, let's just copy these compounds that we want to include in our flash drum, and we just paste it on top. These are the desired compounds, right? And to select, or rather to find the compounds, to find the correct compounds, we just have to Control F. That will get you the find interface. So let's go and select this whole row, and we do a Control F, and then we put air. Now that's a problem, because apparently when you try and Control F and find air, you can't find anything, because this is actually a formula. It's not actually quote unquote air. Like if I type air here and I Control F air, it will give me the cell C121 where air is. So how do we work around this problem? Now we can do a very simple trick. So I want to select all the compounds here, right? I'm going to select all the compounds here. So what you do is Control Shift and you press down. So press the down arrow key, and that will give you the whole compound list. So to turn this into words, so we just have to copy the values over without copying the formula. So I'm just going to paste in the same cell here the values to replace the formulas, and I'll get what I want. So let's say I want carbon monoxide. So that will return me this cell being highlighted in white. Or if I look for carbon, I can look for these three things. So it gives me these four: carbon tetrachloride, monoxide, dioxide, and disulfide. So well, we have solved two of our component problems, which are carbon monoxide and carbon dioxide, and it must be spelled in this particular manner. So let's paste it here. Okay, carbon monoxide and carbon dioxide. Let's also look for water. So water is spelled with a capital W, and just so happens that hydrogen is also beside the water. Just copy that and paste. And lastly, you will need methanol as well, I believe. Methanol. So that will return methanol to you. So all you have to do is just select this array. What I'm doing is I'm selecting this array. I'm pressing Control F to find data only within this array. So try and find methanol. It won't return me. It won't, try and find me the methanol which I've just copied and pasted there. Okay, so that's 5 compounds down. CO, CO2, hydrogen, water, and methanol. So one last thing is nitrogen. So again, let's go and select the whole column, and let's type nitro. So we have nitrogen dioxide, nitrogen, and nitrous oxide. But just get the nitrogen, and that's it. We can select our components as needed. So we have 6 components here, just like we have 6 components here. So now we have done our compound selection. So I'm just going to delete this whole column, and I'm going to cut Ctrl X and paste here. So we have selected our compounds and our property package, which is NRTL and all these compounds here. Okay, so now we want to find what else we need to put in. So we have the Flash algorithm, we have the property package, pressure and temperature, compounds. So okay, we have the compounds. So now we need the mole fractions. So if you actually go to the help file, they'll show you something like this, which is kind of confusing. Well, and you'll be seeing commas and everything down there, which is not actually very helpful. But just to test, like whether if you put decimals, does it work? Well, upon some testing, yeah, I found out that it works. So let's just paint this white. Okay, so yeah, decimals work. All right. So let's say your first compound in this array, in this column I've selected, this array I've selected is carbon monoxide. So let's say you want 10% of it to be carbon monoxide, 10% of it to be carbon dioxide, 40% to be hydrogen, 20% to be water, 5% methanol, and the remaining nitrogen. So okay, you want to see how much is left, how much percentage is left, or fraction. We have 15%, so let's put 0.15. You have to make sure, of course, as always, the mole fractions must always add to 1. Okay? So these are the mole fractions of the compounds going into the flash drum. It's an overall mole fraction, so usually it's denoted by Z1, Z2, Z3, etc. Okay, so if you have a vapor and liquid mixture, be sure to ensure that there's a proper proper mole fraction being calculated. So you are actually putting in the overall mole fraction of whatever materials you're putting into the flash drum for your flash calculations. So okay, the mole decimals. Yeah, I'm tested with decimals and it works. So we put our mole fractions in decimals and we are pretty much ready to start. Okay, so again, we press the FX because we are not too familiar with the DWsim package. So that will give us all the functions. So let's select PT Flash. So it asks for the property package first. We can put NRTL, which is A114 here, A114, NRTL, press enter. It asks for the Flash algorithm. Okay, so it tells us Flash algorithm 02 for nested loops for VLE and all the rest. We have kind of decided in our past video that we want to use the nested loops VLE algorithm. Okay, so we put 0. Now pressure. Okay, let's just select a random cell to put our pressure in. So J114. Okay. Okay, why not let's do this again. Yeah, just to make it orderly. So pressure and the Flash PT will accept pressures in pascals and temperature in Kelvin. It's just for this particular function, yeah? So let's put a 400 Kelvin at just 2 atmosphere, right? So 1.013 E5 times 2. Okay, So that will give you about 2 atmospheres of pressure at a 400 Kelvin temperature. So let's try this again. Oh, it seems to be raining, but just ignore that. Yeah, hopefully it's not too distracting. Okay, so PT Flash again. PT Flash property package, NRTL, enter. Flash algorithm, we put as 0. Pressure in pascals, here, so you can change it. Yep. Okay, so temperature in Kelvin. So we put this. Oopsie. Sorry. Again, pressure in Pascal, temperature in Kelvin. Now the compound names, which you still have to select. Carbon monoxide, carbon dioxide. This whole part I'm selecting here. Press enter. And just ignore these interaction parameter 1, 2, 3, and 4. All these you can just ignore. And now the mole fractions of carbon monoxide, carbon dioxide, hydrogen, and everything else yeah, I think so, yeah. Yeah, in that order, right? Can't remember the word for that. Yeah, but in that order, carbon monoxide, dioxide, hydrogen, water, methanol, and nitrogen. So you just press enter. So once you're done with everything, press OK. Oh, and it only returns you something called vapor. Okay, so that's not very helpful, right? So you have to do the same thing again. Select. Okay, there will be 4 rows on top, 4 columns. It's a 4-column, and I'm not sure how many rows there are. So 4 columns, and well, enough rows to make sure it displays all its data. So press F2, Control Shift, and enter again, same as what you did before. And there you go. Now we find out that in our vapor phase, we have almost everything as a vapor. You can see the vapor phase. I believe this is a total, right? Yeah. The first row will kind of tell you what the total phase in vapor is. So if it's 1, it means everything is in this vapor phase. Alright? So 100% of whatever thing is in the flash drum is actually in vapor. Then there's nothing in the liquid phase. So it's not very helpful. I mean, no, not that it's not very helpful. It's just telling us that everything is in the gaseous phase, the vapor phase. Okay? So this is for the carbon monoxide, dioxide, and everything. So you can see that the compositions of the inputs and the vapor phase are pretty much the same. So yeah, again, it's telling you that everything of what you put in is going to vapor. So now let's say we change the temperature to try and condense some things. So from 400K to 298K, I should be condensing most of my methanol and water. And you can see now, instead of everything being a vapor phase, there's a vapor and a liquid. So it's 77.67% vapor and 22.32% liquid. And that liquid will contain very minute amounts of carbon monoxide, a little bit of carbon dioxide, hardly any hydrogen, a lot of water, a lot of methanol, and hardly any nitrogen. Okay? And in the vapor phase, there will be lots of carbon dioxide, monoxide, dioxide, 50%, 51% hydrogen, a little bit of water, and a little bit of methanol. So in effect, most of it's being condensed. Nitrogen is 19.3%. So this will tell you the compositions of the vapor and liquid in the flash drum. So if you have a hypothetical flash drum, let's say like this, I'm just going to copy everything here, and I'm going to paste it here. So you have a hypothetical flash drum with all these compositions going in, at a particular temperature and pressure, you will get these vapor and liquid. So that is the PT Flash function for you. Hope you have enjoyed this video and you find out there's more than one way to do thermodynamic calculations. You don't need HYSYS to do it. You can have the DWsim do it for you for free on your Excel, or do it using the DWsim suite, which I didn't show you yet. But yeah, you can do it on Excel without too much effort. Within 1 hour, if you follow this video series, it should be okay. Yeah. Thanks for watching, guys. Hope to see you next time, and probably next time, if time permits, I might be producing videos, future videos of other things you can do with this DWsim suite. Okay, thanks very much. Shall see you. Bye.